What is NASA investigating beneath the ocean's depths? Indeed, what mystery exists nearly 10 kilometers beneath the surface of the sea that has sparked such intense curiosity from NASA? The agency sends its expert researchers, referred to as aquanauts, to live and work underwater for extended periods as part of a unique initiative known as Project NEEMO NASA Extreme Environment Mission Operations. But that's not all. NASA also utilizes a robotic submersible known as Orpheus, an autonomous underwater vehicle currently descending as far as 10 kilometers beneath the waves to carry out scientific exploration. Yet, the core question remains: why is NASA exploring the ocean in the first place? After all, the United States already has an established organization dedicated to studying marine environments, the NOAA National Oceanic and Atmospheric Administration. So, what's really going on? Has NASA stumbled upon proof of extraterrestrial organisms hiding in the ocean's depths? Or is there an impending global disaster that NASA's researchers may have already detected? Renowned geophysicist Edward Bullard once made a thought-provoking statement. Roughly 2/3 of the planet is covered by oceans, yet we possess more information about the terrain and atmospheric conditions of the Moon and Mars than we do about our own sea floors. This quote underscores just how extraordinarily challenging it is to reach and examine the ocean's bottom. With this immense difficulty in mind, NASA has imposed a strict 2-month deadline to carry out this ambitious undersea expedition. Why the rush? What are NASA's scientists truly thinking, and should the rest of us be worried? At this moment, NASA is orchestrating a high-risk mission, one that I've personally been anticipating for over 6 years. Among all marine life, an estimated 90% inhabit a region called the Sunlight Zone. Why? Because the further down you go into the sea, the more drastically the water pressure intensifies. In fact, for every additional 10 meters in depth, the pressure increases by 1 atmosphere. Remember the Titan submersible incident? That craft suffered a catastrophic implosion at a depth of just 3.5 kilometers below the ocean's surface, instantly vaporizing the occupants in less than a millisecond, so quickly that they couldn't even register pain. Now imagine this. NASA intends to venture to a depth 3 times greater than where the Titan was destroyed. But why take such a colossal risk? The reason is that NASA is preparing for a massive extraterrestrial exploration mission to a celestial body within our solar system, one where indicators of possible alien life have been observed. Before embarking on that journey, however, the agency must thoroughly examine Earth's deep-sea habitats because, fascinatingly enough, it's believed that life on our planet originated in the ocean's depths. According to NASA researchers, life as we understand it depends on 3 essential components. 1. Water. 2. Energy. 3. Chemical building blocks. Even though humans are intelligent and conscious beings, we are fundamentally composed of lifeless atoms, governed by the same physical principles as everything else in the universe. Elements like carbon, hydrogen, oxygen, and sulfur, among others, must combine in a specific fashion for biological life to arise. But merely having these ingredients isn't sufficient. Think of it like this: having tea leaves, sugar, and ginger won't automatically make a cup of tea. You still need water and a heat source such as gas to bring it all together. Similarly, during Earth's formative years, water and an energy source were vital in enabling those essential elements to react and form complex life, something that happened far beneath the ocean's surface. You might wonder, how is energy available in such a pitch-black place, so far removed from the sun's rays? The answer lies in hydrothermal vents, essentially underwater geysers or volcanic systems that emit scalding water, minerals, and steam directly from the planet's hot interior. Some of these vents can heat the surrounding water to temperatures of 400 degrees Celsius, which is hot enough to melt metal. This kind of geothermal energy is thought to have played a crucial role in the formation of early RNA chains, which in turn gave rise to primitive organisms like bacteria and viruses, and eventually to multicellular life forms. Drawing from these discoveries, NASA is now searching for comparable environments on other planets and moons. But which space bodies are most likely to support life? Well, Mercury is too near the Sun, Venus has an extremely acidic atmosphere. And although Mars has been heavily studied, it has yet to show definitive evidence of liquid water. The outer planets, like Jupiter and Saturn, are gaseous giants with no solid surface to land on or explore. But their moons? That's where things start to get exciting. One moon in particular stands out: Europa, the fourth largest satellite of Jupiter. According to NASA's analysis, Europa conceals a massive saltwater ocean beneath a thick crust of ice. Earlier missions like Voyager in 1979 and Galileo in 1989 took close-up images and collected spectral data, revealing that although Europa's surface is frozen, its interior remains warm and dynamic, kept in motion by gravitational forces from Jupiter that create what's called tidal flexing. This internal movement produces geothermal heat, maintaining the hidden ocean in a liquid state. Even more intriguing, scientists suspect that Europa's subsurface ocean might contain twice the amount of water found in all of Earth's oceans combined. Hydrothermal vents, which are essentially underwater fissures that emit heated water, also contain crucial elements necessary for life, such as carbon, hydrogen, oxygen, and sulfur. This is the exact reason NASA is preparing to launch a spacecraft to Europa, aiming to investigate potential extraterrestrial life. However, this isn't just any ordinary space mission. This endeavor is monumental and visionary, one that captures the imagination of every space agency around the globe. To put things into perspective, India's Chandrayaan-3 had to perform 5 elliptical orbits around Earth, using a gravity assist technique often called a slingshot to reach the moon. But when it comes to traveling all the way to Europa, NASA will employ a complex gravity assist strategy resembling a pinball game, using Mars and then Earth to gain speed before launching off toward Jupiter, almost like a ping-pong ball being flung across a table. Consider this: Europa is approximately 1,600 times farther from Earth than our moon. If you imagine the moon as the building right next door, Europa would be as far away as a journey from Mumbai to Delhi. To get there, the spacecraft will need to navigate hazardous asteroid fields, avoid the gravitational forces of massive planets and their moons, and withstand the highly charged solar winds traveling through space. This intricate mission will begin with the Europa Clipper, a satellite scheduled for liftoff in October 2024. It will first perform a flyby of Mars, then return to Earth for another gravitational boost, and only then will it set its trajectory toward Jupiter. The trip will span 7 years, with the spacecraft reaching Europa sometime around 2031. Upon arrival, the Clipper will execute multiple close passes of Jupiter's moons, eventually entering into Europa's orbit. Once in place, it will begin gathering data, measuring surface characteristics, gravity fields, temperature variations, atmospheric conditions, and wind patterns on Europa. Following that stage, NASA plans to deploy cryobots. These are robots designed to bore through thick ice using nuclear-powered heat. These robotic probes will melt their way through ice layers between 2 to 20 kilometers thick, eventually accessing the concealed ocean beneath Europa's icy crust. Once through, the cryobots will release 48 miniature swimming robots, which will explore the subsurface sea and search for traces of life. Sounds like something out of a science fiction film, doesn't it? And just imagine, what if we actually discover alien organisms? What would their biological systems be like? What emotions would surge through humanity upon realizing we are not the only life forms in the cosmos? The possibility of finding life in Europa's ocean is real and grounded in science. Even after decades of astronomical exploration using tools like Kepler, Hubble, and the James Webb Space Telescope, we still haven't found definitive proof of life beyond Earth. That said, we might be limiting ourselves by searching for life that follows Earth-like patterns. What if alien life doesn't resemble anything we've ever seen? We could be looking in the wrong way, or even the wrong places. Yet despite these uncertainties, the most brilliant scientists on the planet, from various countries, backgrounds, faiths, and belief systems, are setting aside their differences to collaborate on a mission that may only have a 1% chance of success. This is the true embodiment of human spirit, an unwavering drive rooted in our innate curiosity. Even in the face of failure, missions like this help us advance humanity's capabilities, pushing the boundaries of science, engineering, and technology. So, with that in mind, let curiosity guide your journey, because there will always be more to learn, more to uncover, and more ways to grow.